Okay, interesting. I do understand why you might panic. Nah, I'm not going to bother doing that. You know, it's a little frustrating, but it has happened. The problem with the selectability, like I say, not a massive problem, but it's a problem. Guess what? A little rooting round, and there is. Hi guys, welcome to the channel. So today, I'm at a little bit of a mystery job. Now, I haven't seen what's going on here. So this is for a subscriber, and he has messaged me and said, can you come and check over these electrics that we've had done in this rather posh lean-to store? And I obviously said, yeah, no worries, I can come and have a look at this for you. Do not panic. So here I am, I'm having a look at it, and the client has said he has been subscribed to the channel for quite some time, and he has been using lots of hints and tips, which is what it's all about. And he, unfortunately, he employed another contractor to come in and sort stuff out, and he just wasn't quite happy with the finish. Now, this is why he's asked me to turn up, and he has added on a load of other stuff that he wants doing inside the house, if we have time, which I'm sure we have. The client is very particular, and he's done a fantastic job building this beautiful room, in fairness, because it is just essentially a lean-to on steroids. And he's made it very smart, and you can clearly tell he takes great pride in what he does. So, as the job's gone on, he's put in all the conduit work, and he said to the previous Sparky, right, I just need you to come and wire it all up for me. I've done all the conduit work, mounted everything up, and you need to come and sort it. Now, that's fine, not a problem. I would be like, yeah, winner, I haven't got to do the conduit work. So what we've got is we've got a supply back to the board this end, and a new board fitted, and if you can see this armouring, so this armouring goes out to a garage down there, which is not terminated yet, it's future plans apparently. So the client's actually lined it all up, so it comes in through here, what he was hoping for, and the other Sparky has decided, nah, I'm not going to bother doing that. So he has knocked it in to this one rather than this one, which has been planned for, because if you come down here, you can see this is how it's left. So the client's actually lined it up to come in all the way through, and now this is how it is. So the customer's asked me to get rid of all this, take this off, remove this, put it into here, and I said, look, yeah, that's fine, but you're gonna have a hole here, so we're gonna have to put a grommet in there rather than changing the whole thing, which, you know, is a little frustrating, but it has happened. Also, looking at this, like I say, I've not been to this job. I've got an RCD here, and I believe I've got an RCD at the other end, which is very frustrating because you will get a problem with what's called selectability. So if you don't know what selectability is, it is when you've got two RCDs on the same line and a fault happens, you don't know whether it's going to trip out here or the other end. So it gives you a selectability problem. Now, the way to get round that selectability problem is you can put a timed delayed RCD in, which are absolutely mega money. So that being said, the other way around it, which is what most people will do, they'll either control the inside stuff, which I imagine this is how I would do it. So the inside stuff, because the cable will be buried with less than 50mm depth within the fabric of the building, all that cable needs to be RCD protected. So RCD protected at the other end and a main switch up here. That would be the way to do it. So that would mean that everything in here would be covered. The other way of doing it, if you haven't got that and it's an armoured run out to, say, the garage, for example, all the way through, it's got mechanical protection, you could just use a MCB on one end, an RCD main switch, or RCBOs at the other end, and then that would be the other way, but not in this installation. So we're going to knock the power off, we're going to drop down, I'm going to show you quickly before I do that what the client's done, what he's explained to me is installed in here, and yeah, let's start delving a little bit deeper. So before we do that, and you haven't yet subscribed, make sure you do. The link is in the corner. Turn your notification on. Oh, went a bit French. Turn your notifications on, and yeah, you'll get a little message to say we've dropped another quality video from the GHC. So yeah, if you're wanting to be learning more hints and tips, then do that right now. Come on, got enough time. I'll wait. Cool, right, I'll show you the installation. So the customer has got a double socket here and here. He's then ran some conduit up all the way across the top. As you can see, and we have got a double socket here and here. Just outside there, there is a security light and some, yeah, so then that also, the conduit runs down just down there, and there is a double socket outside there. So that is that installation. And then this side, we've got some more conduit work that leads up and goes out to another security light on the outside there. Then obviously the board is what it is. Looks like I've got 2 spare ways. Looks like we've done a left side and a right side, I'm guessing, and then a 6 amp lighting circuit. So let's turn the power off and get inside. As expected, it has got an RCD at the other end. So there is a split load board incoming, okay? So what that is, you've got an RCD, set of MCBs after, another RCD, another set of MCBs, and so we've got the problem with the selectability. Like I say, not a massive problem, but it's a problem. Okay, so we're now dropped off the lid, as explained before. This is going to be the future for the garage supply, and it's not connected for the live and neutral, but he has connected the earthing conductor. I don't know why. So he's used singles for all the conduit work, which is the right type of cable for that installation method, which is fine. What I wouldn't have done myself, I wouldn't have doubled them over. You can use some ferrules because that's just a bit easier, a bit neater job, being fussy. But there's no real cable on show. Yes, could we make that tidier? Yes, we could. But hey ho, it is what it is. Now, one of the other things I would say though, is that we've got no earthing arrangement for the actual armouring. So I would like to see a banjo on there or an earthing nut. But if it's not on this end, then potentially you could do it at the garage end down there. So being fussy, yes, but that's what the clients asked me to be. So we've got a 10mm supply coming in, so that's coming through, and obviously that is now wound up and into the terminals. Now I can't see anything massively untoward, other than now we're going to have to move that over to here to sort this out. So first things first, let's disconnect this and get this out, and then we can redress all of the bottom in and get that job ticked off the list. Okay, I think it's important to note the power's still on here, this end, which will mean we're going to need to lock off the other end. Now, if you don't know what lock-off devices are, basically get yourself some, they will save your life. So effectively, you'll have a lock and some sort of locking device to make sure you can turn the breaker off at the main end, because I can't see what's going on in that house. Someone inadvertently could accidentally turn it on, think, oh, something's tripped out, and just go bang, 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 turn it on, and potentially I'm working in a live board. So we need to make sure we get that on right away to make sure we've got a nice, safe installation. Okay, all locked off at that end, and there we have it. Nothing coming through. No risk of me getting hurt. So, yeah. Now, start stripping it out. Okay, so we've disconnected all the armoured. The armouring's all off, unclipped from all here. So I've now just drawn a level line all the way down and put in the knockout this side now, as the client wanted previously. Draw my line down. That line there is for my cleats, so this is where I'm going to drill in, and I'm going to show you how we then go about measuring out to get this in the right position. And this is why I think the previous guy left a ton of slack down there and thought, oh, I don't know what I've done. So he's either done one or two things. He's either knocked that out straight away without thinking, or he's got too much slack at the bottom and thought, oh, do you know what, I'll just leave it like that and that will be good enough. But I'm going to show you an easy way to basically mark these out, and you can get it right first time. So it's always a little bit more awkward once you're doing something like this, where you've got cable that's already been cut and all the rest of it. It's a little bit more awkward. But what you've got to try and do, see, if I've now put the armoured in place, so you hold it up tight and you eye it through So I'm going to try and just let go of this. Hang on, I'll try and fix you onto something. Hold on. Here you go. Here you go. Right, so you're going to try and eye it through from, this is your cut line. So on here. So this is your cut line. And you try and eye it through, knowing there, so you're going to need to cut around here. That's going to be your first mark. So I know it's not much, but this makes all the difference. So I'm now going to put my cleat in, which is just down here. So I know I've only got a little bit of room to maneuver. And the cleats that we're using, they're number 7s, which is the right size for this cable. And essentially it goes round like that, and obviously fixed through, and then that will pin it to the wall. So yeah, so if you can see, it's the right clamp rather than zip ties. Zip ties not a correct installation method. So a little bit of fingers and thumbs at the minute. So I'm going to get that fitted on a bit further down, and then we can mark this up and cut it then. So job number 1 done. We've moved that across. I've also put a fire stuffing gland in there for fire sealing gland on there. Just need to give it a little wipe. A little bit of a wipeage. Keep her clean, keep her clean. So that is in. We've also put the earth flying lead in, so it's ready. So whoever does the other end hasn't got to bother both ends, it's all sorted. We've taped it all together, and then we just took that out of the way. Now what I did notice, which I found a bit strange, is that that screw and that screw are completely different, and this end wasn't even tightened, so the whole load of connections could just flap about in the wind. So I've just tightened that up and sorted it, but I don't understand how that's been lost, but whatever. So the next port of call for me is to start getting on with dropping some of the fronts off, making sure they're okay, and then we'll start doing the actual testing of this building. Now obviously we're going to keep it all dead at the minute. We don't need to bother faffing about too much with getting any power back on, because that would be a mistake. We don't need to do that now. We're going to do all our dead testing on the sockets and the lights, and see what we are working with. Now like I said, I've got 2 socket circuits on there, so I'm guessing that we've got a radial to the left, radial to the right, and then that should be just the straight lighting circuit after that. So let's get the tester out, let's clear some of this stuff away, get it out of the way, neaten it all up, because it is such a neat, tidy little store. While I get stuff set up for my testing, so testing wise, we are going to be using a multifunction tester. I use the Mega, always have done since I left college. It's a brand that I've just stayed with. So before I go too far, now like I say, I just want to point out there is no power to this building whatsoever. It's locked off at the source, so we're all good to go. So I don't have to worry about anything else right now. So what I want to do is do an initial verification and find out what socket circuit does what. So there's a few ways I can do that. I can disconnect the cables inside the board, or also we can use this, I think it's got an R1 plus R2 link, I think. But essentially it's got a magnet on one end and a clamp on the other. So what we're going to do is going to link it onto the earth bar and then put it into the MCBs, and then that will stay in place like that. So we're going to go to our continuity on our tester and try and figure out what's what. So right here there is a socket just there, and either there's no earth path all the way through, or I've got nothing coming through. So let's hope, fingers crossed, we move down this end where these sockets are, and let's hope that we've got something. So I've got nothing on there. Okay, interesting. So is it that this is one and the second circuit is the socket that's just outside there? Let's go and find out. So just down here, there is a IP rated socket just here. A bit jazzy, isn't it? A chrome number, very nice. Okay, so I'll come back to this in a second. Aha, here we go. So I've now, I don't know why this is, the backlight is not great. So I've got 0.17, so it is true. I've basically got this one circuit that is linked back from here to the board, and the other circuit must be just for this one. Now, I quickly want to point something out. So this type of RCD socket is not required. Again, you know, at the start of the video about selectability, don't need this. This is massively, massively overkill. Do not need to have that socket there with an RCD built into it. It's just a recipe for disasters moving forward in the sense of selectability. So if you had a fault there, there's no power. You've got 3 points, that is now. So the one there, one in the main house, to figure out where the actual problem lies. So that's one thing. So what we now need to do is record that result down. So it was 0.17, which is my R1 plus R2, and then we need to do our insulation resistance test on that socket. We're now going to move our lead over to this side, and then hopefully, fingers crossed, it should mean that that will be this socket over here, this set, and the set down there. So let's just take the tester and figure out what we've got. And there we go. So 0.44. Now we need to do every set 0.35. Now remember the highest reading, so 0.44, okay? So we jump over to this side. 0.17, 0.26 we've got. So our highest results, 0.44, we just need to enter that into our certificate. Hold on, I can show you this. So hopefully you can see the screen. So we've got 0.44. So mine are already preset. So obviously it's not a 610009, it's a 60898 type B, which is what that needs to be. It's a 16 amp. So my maximum permitted ZS is 2.73. So now I need to change this, need to clear that and put a description in, and we're going to put shed sockets. So now we need to count out how many numbers of points we've got. So we've got 4 on this, and then that's as far as I'm going to go right now, because we're now going to come on to our insulation resistance testing. So they're already preset on the software that I use is 999, which is 999 mega ohms, which is a perfect result. So let's see what we've got. So we're now going to disconnect our supplies coming in to here. And like I say, everything should be collated for what that is for numbers wise. So what we're going to do, we're going to connect our earth to our live, hit our test, and that's going to push the voltage through 999 mega ohms on there, and then we're going to repeat the process through live to neutral, and so on and so on. So after this one, it will then be, we'll then go to our neutral to earth as well. But if you can look on here, so my live to neutral, there's a problem. So at this point, some inexperienced Sparkies would actually panic. And I get it. I do understand why you might panic. But there really is no need. There's no need to panic whatsoever. It just means that there probably is something still plugged in that I've missed, and I've not quite remembered where all the sockets are. Maybe there's more sockets that I've missed. And guess what? A little rooting round, and there is. So having a little look down here, you might find, oh, there's another socket there with something switched on and plugged in. So I bet you, if I turn that off, remove the accessory, and the floodlights are connected to this one, are switched off, I bet you that fault's going to clear. But before I do that, if it clears, you've got to promise me something. This has got to be worth you to subscribe. Now, link's in the corner. Come on. That's a free tip right there. That has got to be worth a subscribe to us. Come on. Right. Thanks for that. Really appreciate it. And here we go. Moment of truth. Bosh. And thanks for your subscription. Woo. I'm now looking at sort of tidying this up. Now, what I'm going to do is, like I mentioned earlier on about the bootlace ferrules. So we're now installing these because it is multi-strand cable and they should really be installed when you're using such type of cable. Now, I personally think it's just actually makes your life easier. You don't have to double everything over. It's not expensive. You don't have to be going, oh yeah, it's going to cost you an absolute arm and a leg. It doesn't. It's not. The kits are cheap. They're not expensive. You can buy, don't get me wrong, you can buy expensive ones if you want, if you're, you know, a sadist. But you don't need to. So what I'm going to do is I'm going to show you this one quickly, and then I'll get through all of them. So you get your bootlace ferrule like that, put that on, slide that down, get your crimping tool, squash it down, job done. Then you can put that back into the MCB, tighten it all up, and make it all a proper, decent connection. Now I'll go through all these. Now I could spend hours just tidying everything up, making sure everything's all swoops and all the rest of it. But I'm pretty sure from the customer's point of view, because he's added on loads more work that he wants doing, he'd rather me just spend a bit more time on the other stuff that we've got going on, and rather than worrying about some cables that are in there, which we can sort at a later date if he wants to. I've now installed all the ferrules, so they're all on, and done a little bit of a tidy up on the cables. Nothing crazy because, like I said, there's bigger fish to fry. Now, what's left now, I'm going to do I've done my lighting. Lighting was fine. I got a R1 plus R2 of 0.32, which is fine. Insulation resistance is 999 all across the board on all the sockets and all of the lighting. So that is a win-win. So we're now going to do a live testing. We're going to do our ZE at the board, which means I'm going to have to now go back inside, unlock the device, energize it, and then I'm going to show you the problem with the selectability as we stand right now. Lock off kit removed, so it is now energized, so we've now got power up to this board. Now, I don't have to worry too much about doing it directly there because I've got a socket access. We can just do it there because that RCD covers the entire lot, because we're testing the RCD, not the RCD on individual circuits like you're on RCBOs. So what we're going to do is we're going to change the leads in the tester to put our plug top in. It's very handy having a nice, neat, clean room to work in, I must admit. And even where the board is in the main house, that's amazing too, because it's all cleared out. So we're going to use this socket, which is just here. We'll switch that around to RCD testing. And it's 30 milliamp RCD, which is what we've got. And we're going to test it at 1 times its current value. Oh, it's not going to do that until I turn the power on. That would help, wouldn't it? So turn the power on. We'll get these sockets energized because that would also help. So I've got 35.5 at 180 degrees on its cycle on there. So we need to change that round. So remember that 35.5, remember it for me, because I will forget. So, you never know. It might have stayed in this end. See if you see on here. So now, if you notice, I've got no voltage coming through. Although, that is energized, and this is why. And there you have it. Okay, so you've got this RCD tripping out at the same time as that one. So now I have to reset that one, and then that will make that one live, which then will give me, see, I've now got my voltage on there. I don't know whether you can see that very well. So I've now got voltage, which means I can then go again, because I'm now at the 0° cycle. 25.8, which has then tripped that one, and no doubt the one in the house. Hence the reason why you don't fit multiple RCDs, unless it's a time delayed RCD, on the line. You don't need to do it. Now, the highest result was 35.5, which is what we put into our certificate, which is what we've done. And that's it, basically. That is the RCD testing on there. So that's great. So we're going to do our ZE, which we will do that in a second, but I now need to go back in the house and energise it again. Okay, so we've got a ZS value here at this distribution board of 0.21 with a PFC of 1.1. So I now need to obviously label up what that is. So obviously in the certificate we've got our DB reference, which is DB, well, this is actually going to be DB2. So the ZS at this board is 0. What did I say it was? 0.21. And the PFC was 1.11. And the main switch, you need to obviously change it because it's not a 60947. It's a 61008 RCD, which is what it is. And obviously it's rated at 80 amps. So this is on the details, all in the details on your certificate. You need to make sure that you've got the correct information all the way through. So just in case you're not quite sure, then double check. Okay, there's nothing wrong with double checking and making sure everything is absolutely spot on. So it's a little bit frustrating that this has been installed this way, but hey, it is what it is. So that is supplied by a 10mm. It's twin and earth. So DB location, we're going to give that. I'm going to put that on the side as a side shed. And it's supplied from, so this is where the key in the details is supplied from main board, and I'm going to put a little bit more detail in there. Circuit number 6, which is what it is. Okay, so that is where the certificate is. Got to make sure your details are on there, and then, like I say, once you've gone through all those, we can then label that all up a bit nicer so everyone knows what they're doing. And yeah, get on with the next part of the project. Another part of this job which is vitally important is your visual inspections, because let's face it, I haven't installed any of this, and from what I've seen so far hasn't been of the highest standard, and a few little things have been basically missed. Now the visual inspections are really, really important. So you want to be doing a sampling. So you want to take socket fronts off and have a look, accessories off, have a look to see how they're installed. Is there copper on show? Is there things like the earthing flying leads installed? Because we've got metal accessories, so there's metal back boxes, metal accessory fronts. And let's just show you. So I took my first one off, and as you can see, we have an earthing lug and no earthing conductor brought through to the front. Now some people might go, well, actually yeah, but it's all terminated because of these, so when these are on, that'll be fine. Well, it's actually not okay, because if you're undoing that and that is for some reason that's loose, that now is no longer earthed. So you need to make sure that these are all sorted. And I thought, okay, maybe they've just missed one. So I went to the next one, dropped that off, nothing. Came down this side, bang, nothing. You get the picture. So it's a process, in my eyes, that's been completely missed. So that's something now that I'm going to sort out. Going to get all those earthed, but these are all knock-on effects of, hey, look, you know, if I've got time to do everything else, brilliant, I'll do it. But if I haven't, my priority is making sure that this room is safe for its use. So we're going to sort that out right now. We're going to get on with those. Now, recommendations, what I would have done for this, I would have fitted any board that I install would have surge protection device fitted at the source, especially if you've got an additional board like here. I'd put one in, because you don't know how far you're going to go. You might have an EV that go, oh, actually I'm going to install it from this end or whatever. But always install surge protection devices in your property, because it will save you an absolute fortune. Now, like I say, if you're enjoying this video so far and we've got to this point, then and you haven't yet subscribed, please make sure you do. Like I say, we try and share as many tips as we possibly can to help you guys at home understand why it's so important to use a qualified electrician that will take care of your job and ultimately make your house safe. So if you haven't done that, please make sure you do. The link is in the corner. Turn your notifications on, and we drop a video every single Tuesday night at 6:30. And yeah, so thank you very much. So what I'm going to do is I'm going to sort these earthing out now, and all we've got is just a bit of singles that we're going to make up some flying leads and just bosh all those on. Okay, so that is all earthed now. We're all sorted. So we've managed to get all of the fronts all earthed with the flying lead, which is fantastic, all done. So one of the other things I forgot to mention is about the RCDs is the functional test. So it is simply to make sure that you're functional testing the RCD, okay? So that is where you've got your board, you will see a test button. So any consumer unit that has got an RCD in there will have a test button. So it says test 6 monthly. You press your test button and it should trip down. Should be fairly straightforward to reset. And that should be it. Now you might be thinking, why on earth do you have to do that? Now the reason you do that is to stop them sticking. Because let's be honest, have you ever done that in your house? And I would put a lot of money on that you haven't. So every 6 months you are supposed to test those RCDs, and it's to stop them sticking, because if they stick, they cannot trip out under a fault condition, which means potentially you've got a dangerous installation. Sounds extreme, but that's what it is. So every 6 months, make sure you go and test it. Now I guarantee that you'll now be thinking, oh, Derek, love, have you been and checked that? Well, I bet you Derek hasn't. So go and do it. And yes, it's a little bit of a pain because you've got to reset all your clocks and all the rest of it. I get it. But is it more of a pain if you actually, something happens and you have an electrical issue, fire or electric shock, whatever? How much of those clocks are that annoying right now? Not very. So anyway, so on that point, we have now tested out the whole installation, so we are all good to go. We can issue an EICR on this section, and it's now been commissioned, ready to go. Moving forward, down that end, obviously we have got the garage. Now the garage itself is a later down the line project, but we are all good, ready to go. And now hopefully I'll be back to do all those electrical installations properly for them so they can get it right from the onset. So things that I would recommend for the client, so if we were going to be doing this from start to finish, would be changing that main switch, getting that gone, and just putting a standard main switch in so you don't have the selectability issues. Also change that socket, which is just down there, from an RCD socket to a standard socket. It takes, again, all that selectability issues away, and potentially, because as the client is doing more and more stuff in the house, that maybe it would be a good idea to upgrade the main board with a surge protection device as well. So hopefully you've enjoyed this video, and if you have and you haven't yet subscribed, I know I keep banging on about it, but it is amazing how much of a difference it makes to me personally when you decide to join this electrical community. And yeah, and it just shows a little bit of appreciation that you've enjoyed the channel and enjoyed this video. So give us a thumbs up, and we shall see you on the next one. Take care, guys.